Moving on from looking at correlation, we are now going to have a look at regression. So in a scatter graph, if y can be sensibly predicted by x, then we call x the independent or explanatory variable, or the control variable is another way that we can describe this. And y is called the dependent or response variable. A line of best fit, we are usually going to call that now the least squares regression line, and usually that will also say y on x, which means that y, what we are measuring, depends on how we are changing x. So that's very important that we are using y on x and not x and y, and it's because x is the independent variable and y is the dependent variable. As you'll remember from the section on PMCC and SRCC, we're going to be using y equals a plus bx. There is also formulas for calculating a and b from summary statistics. However, that's going to be covered in the summary statistics part, and we are just for now going to be using our calculator to do so, to answer these questions. So first of all, we need to plot the data on the scatter diagram, and we need to calculate the value of the PMCC. So the scatter diagram is just on the next page. So we need to plot these points on the graph. I am going to pause the video to do this. For more information on this, please watch the scatter diagram video. Just pointing out the scale of the graph. Each little square going across is going to be worth 0.2 because we have 5 little squares going between 0 and 1. And each square going up is going to be worth 0.04. So, oops. Sorry, thought I had a pen then. Each square going up is worth 0.04. Each square going across is worth 0.2. So do be careful when plotting your points that this is being taken into account. So hopefully when you've plotted your data it looks something like this. I'll just talk through some of the points. So 5.7, which is going to be here. Going up, we wanted 6.12. So like I said, remember in each little square going up is worth 0.04. So that'd be 6.04, 6.08, 6.12. So that's directly on the line there. 6.5, 5.9, exactly halfway between 6 and 5.8. Again, another good one to have a look at is the 9.5, so second to the end, 9.5, 5.32, so that's 5.2, 5.24, 5.28, 5.32. So like I said, you need to plot the data carefully when you're putting it onto your scatter diagram. So we're then asked to calculate the PMCC. So I'm just going to flip back to the question. So now we need to type our data into the calculator as we did in the PMCC questions. So, whoops, sorry about that. So 5, 5.7, 6.5, 7, 7.6, 8.5, 9.5, 10.5, and then 6.21, 6.12, 5.9, 5.62, 5.25, 5.41, 5.32, and then 5.11. Just quickly double checking that I've typed the data in correctly. Remember that you should always do this after typing something in your calculator because you are just going to get the value straight from the calculator. Calc, reg, x, a plus bx. And from having a look at the graph, we would be expecting to get a negative because we can see here that we have, as the data for the load is increasing, the fuel consumption is decreasing. So we can see there that it's taking more fuel to go the distances with the higher weights, which is what we would be expecting. So the actual value for the PMCC, remember that's this R value here, is minus 0.921 to 3 significant figures, Remember to round to 3 significant figures at the minimum, unless told otherwise. So for this data, is it appropriate to use a regression line, and why? Well, in order to use a regression line, we are wanting a linear relationship. If we have a look at the data, it looks like there is a linear relationship going on here. We can see that it's definitely going down. The fuel consumption per kilometre is going down as the load is increasing. And also we have a high PMCC value, which suggests again that we have a strong negative linear correlation. So is the regression line good to use? The answer is yes. A regression line is appropriate as we have a strong negative linear correlation between the load and fuel consumption, and that's meaning per kilometre, of the lorries. And that's going back to the interpretation of PMCC from the Calculating PMCC video. So now we're asked to use a regression line to calculate some values. Oh, sorry. Part C, calculate the equation of the regression line and plot it on the graph. So we've got our graph here. We've already put our data into the calculator. In fact, we are in the right part of our calculator. So remember, not only do we go to calc reg x a plus bx for PMCC, but we also go in here to calculate our regression line. Now at the bottom of the screen, we can see here, we are writing it in the form of y equals a plus bx. And at the top here, you can see a equals this and b equals this. So that tells us how we write our equation. So you have to have y equals, or whatever the variable on your y-axis has been labelled as, a, which is 7.15 to 3 significant figures. Remember, a minimum of 3 significant figures. You could put more there if you wish to. Then plus b, but b is a negative number, so we can change the plus to a minus, 0.203x. So that is our y equals a plus bx. And if you think back to GCSE, the coefficient of the x, so this number here, the number before the x, is the gradient of the line. So yes, we would expect to be having a negative gradient if I was to draw the line of best fit on here. And the other part of our equation would have been our y-intercept. And if you think about this data, if you were to continue the line, it would go up past our 6.66. So yes, that seems about right. An important thing to note is that we should not extend the line so that it actually goes through this point here. And we also shouldn't try and make it so our line passes through the x-axis. The reason for these two being is if we have a look again at the scale at the side, this isn't going 0, 1, 2, 3, 4, 5, 6. This is going up in very small numbers up the side, and it doesn't start at 0, it starts at 5. So we only want to draw our regression line in the area that we actually have data for. So in order for us to plot our regression line onto our graph, I'm going to use a new part of the calculator. So if you go back to menu, so you've got all the options here, we're actually going to use the table function. So this function here. Now in the table function, you can type in your equation. It's already got the y bit there. So we just need to start typing the 7.15. So 7.15 minus 0.203. And in the same way as we did for interpolation, we're going to use this x theta t button to be our x. Then when we put xe, you can see at the bottom there is a set bit. Now the set tells me what the table is going to show me values between. So I only want to have a look between 0 and 11. And I want to go up in steps of 1, so that's fine. Now the reason why I'm having a look at all this data, so if I click xe and xe again, this has now given me the x and y coordinates of various points on the line, on my regression line. As I said before, I don't want to use anything below 5 because 5 is where my data begins. And I want to try and choose points that are quite easy to plot. Because the scale on the y-axis is quite difficult to use, I want to try and choose some fairly easy to plot numbers. So I'm going to choose as one of my values. You only need to choose 2 values in order to draw a straight line. So I'm going to choose the 8, 5.526 as one of the points. So 8, 5.526. So it's just going to be above that line there. Again, 5.4, 5.44, 5.48, 5.52. So just above that line there. And another sensible point to use would be the 5.12 at 10. So 10, 5, 5.4, 5.08, 5.12. So that's going to be another point that I want my line to pass through. Then, using a ruler and a pencil, you need to draw your regression line so that it passes through both of the points. I'm going to have to move mine a little bit. It's a bit hard to do on here. You need to draw your regression line so that it passes through both of the points that you've just plotted. That's about right now. And like I said, only for within the range of data that we have for now. So we have found the equation of our regression line and we've put it on the graph. And as we talked about before with the regression line, it will pass through the mean point automatically because that's how the calculator has calculated this. So we don't need to bother finding the mean point. But you'll notice that we have slightly more data above and below, and that's fine because these 2 data points that are below are much further away from the line than the data points above, which are quite close to the line. So don't be drawn into thinking that this is going wrong. You're thinking about the overall distance of the points above and the overall distance of the points below, and yes, that would be about right for this. So then we're going to use our regression line to predict the fuel consumption of a lorry carrying 6.9 tonnes, and we're asked then if it's accurate or not. Well, don't actually use your regression line. The reason for this being is that we have the equation of our regression line here, and it's going to give us a much more accurate value using the equation. You can use your graph to help you double check that you've plotted it correctly, but my first point of call would be to use the equation unless it specifically says to use the graph and it just says to use your regression line. So we're using our regression line. We know from this part here, if I just go back a bit, that the load is the x. So I know that I've been given the value of x. So we know that x equals 6.9. So what I'm actually going to put in my calculator now, not the y equals bit, but I'm going to have 7.15 minus 0.203, just double checking that, yeah, times, and then instead of x, I'm going to have that 6.9. So I can actually just put that into the normal calculator part. 7.15 minus 0.203 times 6.9. And that gives me a y value. My prediction is 5.75 to 3 significant figures, kilometres per litre. Now the question of if this is accurate or not is leading us back to having a look either at the data or at the scatter diagram. If we had a look up from 6.9 on our graph, we would intersect where we've drawn the line. And if we have a look at the data that we have here, we can see that we have some x values either side of 6.9. We've got 6.5 and we've got 7. So we know that 6.9 lies within the data, which means that this is probably an accurate estimate of the fuel consumption. So is it accurate? I would say yes, as 6.9 is within the range of data given. And this also has a special name that we have used before, which is interpolation. So then it also asks us to use our regression line to predict the fuel consumption of a lorry carrying a load of 11.5. So again, that's our value of x because that's the load. So we're now going to use 7.15 minus 0.203 times 11.5. And when we put that in our calculator, I'm just going to edit this to make it a bit quicker. 11.5. We end up with 4.82 to 3 significant figures. Now, when we're asked again to have a look if this is accurate, 11.5 is off over here somewhere. Doesn't mean it's going to be negative because remember, here we've got 5, not 0, so just be careful with that. And if I go back to have a look at my data, the biggest value that we have is 10.5 in the loads, but we don't have anything above 11.5. So that means that the data that we've just had a look at is not within the range of data that we were given. So this time when we're asked if it's accurate or not, the answer is going to be no, as 11.5 tonnes is outside the range of data given. And again, this has got a special word, which is extrapolation. So those are two key words that you need to remember. If the piece of data that you're looking up is inside the range of data, then the prediction that you use is going to be quite accurate because it's interpolated or used in interpolation. However, if the value is outside the range of data given, then it's not going to be a good prediction as it's been extrapolated or using extrapolation. I'd now like you to pause the video and give the Now You try a go. So hopefully you paused the video and gave the Now You try a go. This time the graph is much easier to plot for part A, plotting the scatter diagram. You can see my purple marks there. Then we're asked to calculate the PMCC, which gave me 0.918. And again, does this mean that it's appropriate to use a regression line? Yes, as there exists a strong positive linear correlation between arithmetic mark and English mark. Calculating the regression line, remember it's in the same place as you got your R value, calc, reg, x, a plus bx. And you write down y equals a, which is 3.62, plus b, 0.685, x. Then we need to use the regression line to estimate the English mark when we have an arithmetic mark of 32. So again, that means that x is 32 because arithmetic mark is along the x-axis. So then in the normal part of our calculator, we type in 3.62 plus 0.685 times 32, and we should have 25.5 to 3 significant figures. So we don't need that 4 there, sorry. So is that a good, accurate value for the English mark? Well, if we have a look back at the data, 32 for arithmetic, well, we've got 33, which is above, and we have 27, which is below. So yes, we have data either side of that value, which means yes, it's going to be an accurate estimate because 32 is within the range of data, so it's interpolation. However, part E is a little bit of a trick question, and I'm hoping that you were very careful when answering this one, because this time we're told that the English mark is 52. So notice that in part D we were told the arithmetic mark, in part E we're told the English mark. And if we have a quick look back here, English is on the y-axis. So this time we were actually told that y equals 52. And when we replace that in our equation for our regression line, we get 52 equals 3.62 plus 0.685x. Now you could spend time and rearrange this. However, I just use the function in my calculator. If you go back to menu, we used this before in interpolation. We go to equation, solver, and you can see there that I just typed in what I had here. 52 equals, which is shift and then the decimal point, 3.62 plus 0.685, and then remember to use the x theta t button for your x variable. Also remember that when you've typed it in, you have to click XC twice so that it comes up with your new answer, which is 70.6. And if we have a quick look at the data again, the highest English mark that we have is 33. We have nothing higher than that. So 52 is outside the range of data. So no, it's not going to be accurate, as 52 marks is outside the range of data given, which is extrapolation. So next time we are going to be moving on to looking at interpreting the values that we get in our regression line. Thank you very much for listening.